Hello, friends. So yeah, as was recently stated by the sultry tones of our host here, my name is Eric Wastl, and this is in fact Advent of Code Behind the Scenes. I really enjoy helping people become better programmers, and when I am learning a language or learning a skill, I find that I do it best in the context of some kind of a problem or scenario that I'm trying to solve. And so one of the goals that I set out to solve when I'm doing this is to give people just like small packaged problems with a single answer that you can think about and work on, and in doing so you learn a skill or you learn a thing. And so I've constructed a mechanism by which I do this. So show of hands, who's heard of Advent of Code before here? Before they saw it on the schedule, I guess. Awesome. How many of you have done at least one puzzle? How many of you have done all the, oh, sorry, hang on. Hello? Wait, it stands for what? You sure CPP doesn't stand for Canada Pearl People? C++? Oh, I'm sorry. Okay, thank you. I'm being told that this is a C++ conference. Is that true? These are the wrong slides. Hang on, sorry. There, okay, much better. How many people have solved all of the puzzles in 1 year? One person. 2 people? Very nice round of applause. That's really hard to do. They're really hard. Some of them are hard. I try to make the beginning ones easy, and I try to make the later ones hard. We'll get into the variety of what that means and why. Thank you to my wife who's in the crowd who set that up for me. Yeah, we have some C++ in Advent of Code too. I'll get into where and how if I remember during that slide, but mostly it's in Perl. I'm not sorry. So, who let this guy on stage anyway? Whoa, don't do that. Wow. Okay. So I used to make large-scale web applications for ISPs. I used to work on auction infrastructure. I used to do architecture for a TCG marketplace. Now I do architecture for that same auction company again. I also run programming challenges. You might have heard of them. Tools for games. When I play video games, I engage with them not by playing the video game, but by playing it for 5 minutes and then being like, you know what this needs? More software. I make fun of some programming languages, and I make lots of other random things, but we're not here to talk about any of that. We're here to talk about Advent of Code. So hold on, what is this Advent of Code thing I keep hearing about, right? So we need to back up for a second. Suppose that you are here. Wait, that's too zoomed out. Sorry, hold on. Let me just, here, at this little cafe in Salem, Massachusetts, and all you have is a pen, a few napkins, a few weeks until Christmas, a random memory of Advent calendars, and a passion for programming puzzles and helping people to learn to become better programmers, right? The answer, Advent of Code, a combination of Advent calendars and programming puzzles. So what's an Advent calendar then? Some people and some like later on in the year celebrate Christmas and similar things, right, by having this thing called an Advent calendar, which is a way to count down the days until Christmas occurs. And very often they'll like older ones look like this, and it's usually like a box where every door for a day has like a treat in it, or some of them have like a Lego in it or something, right, which is super cool. The one that I grew up with has little things that you put up on the tree, one per day until the day is full. And it's just a way to count down until Christmas. The Advent calendars and Advent of Code look like this, or 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 like this. But what about the puzzles part? Well, if you see, each of these lines is numbered. And if you click on one of the lines of the Advent calendar, a little story comes up. And the story is about how the elves were trying to bring the sleigh keys to Santa, but they dropped them in the ocean, and now you have to go rescue them using a submarine or something, right? Something fantastical, and you are the only person who can save Christmas. Somehow, right. And you read through the puzzle, and it ends up getting into some kind of a programming circumstance where not only are you the only one that can solve Christmas, but you have to use software to do it, or graph paper, we'll get into that. And it gives you a button where you can ask for an input file that contains the details of the circumstance that you have found yourself in. And it also asks you to put in the answer. It doesn't want your code. You can use any language you want. You can use pseudocode. You can use your brain. You can use whatever. and you type in the answer. And if you do that, it will give you part 2, where I pull the rug out from under you and either add to the puzzle or make a twist and change the requirements in some way to simulate like a real-world circumstance, or you're on a project and the client comes up to you and the client's like, but we didn't want this button to be blue, we wanted it to be red. And you go, oh no, I hard-coded blue deep in the source code. How will I, right? Simulate like having to change a project that you've already been working on. And so I'll make some tweaks, or I'll make it more complex, or I'll do whatever. And then you put that in, and when you're done, you get 2 stars. And then you do more, and you get more stars. And as you do that, the calendar fills out in one way or another until finally you have a finished calendar, and also hopefully learned a whole bunch of stuff. So it's 2015, and you just built a bunch of programming puzzles. Where should we host this thing? Well, let's do some traffic estimation, right? We're good engineers. We can plan for traffic. Programming puzzles probably won't be that popular, let's be honest, right? There aren't that many programmers, and even if there are, the kinds of people who like solving puzzles for fun is some fraction of that. It's probably not going to catch on, but I do have a few friends that might like it, and they have a few friends that might like it. Maybe 50 people? Now, we are good engineers here, so we're going to give ourselves a wide margin, 70. Should be enough, right? Should be plenty. Small personal web server, I've already got one running. Throw it on there, it'll be fine. Great, okay, it's November 30th, time to launch the site. We announce it, we say, hey, I've been working on this thing for a while. You should go click on it. It's got 27 retweets. That's within our margin. We expected 70, we got 27. Yeah, everything's fine, that's great. This is the sign-up graph leading up until midnight. There's 81, the number of people that were signed up at midnight. There's 70, that's our estimate. I mean, that's still fine, right? We can handle a little more. The web server isn't that taxed. It'll be okay. And then the puzzle's unlocked. And then the graph did this. The technical term for this curve is, oh no! So 12 hours later, the graph looks like this. That's my estimate. If we zoom out a little bit, there's our estimate. There's 4,000 people. So let's review our estimate here briefly. We estimated 70. We actually got 4,000. We're only off by 5,600%. The small server is very sad. So you're bad at traffic estimation. Now what? Step 1, turn off the Minecraft server. That saved lots of resources. That still wasn't enough. Step 2, don't create a new process to handle every request. Hang on, what? Why would you do that? Well, turns out there's this thing called the Common Gateway Interface, or CGI, which I expect many of you in the C++ community have also interacted with. This is very good for prototyping and very bad for getting traffic. It turns out that it lets you set up a process that takes some inputs and some outputs, normal process inputs and normal process outputs in a POSIX environment anyway, right? And it maps those things to the inputs and outputs of an HTTP request. It's really convenient for building quick things and just slapping them someplace, right? But it does this for every single request that comes in, which is explosion. Don't do that. But it turns out if you just switch to fast CGI, which simply skips the step of creating a new process, it's fine. So an emergency switch to fast CGI saved that event, at which point I promptly, oh wait, hang on. There's more, it continued to grow. So hang on, where did all these people come from? Well, the astute among you might have noticed that these 2 lines that I've highlighted are recursive. And all of a sudden, you might know, so there's a website that used to exist called Twitter, where people share things, and they did? And then the graph kept doing this. And it did this for the entire event. So if I just fast forward to the end of December 2015, there's 52,000 people versus my like 50 or 70, right? And just like, where did you all come from? So shortly after, switch to AWS, where I can pay them for more CPUs. That's much easier. Now we have 1,400,000, which is an impossible number to even speak out loud in front of a group of humans. 1,400,000 registered users, of which 930,000 have at least done a puzzle, which is the metric that I like to use when I'm measuring like who's a real user and not who accidentally clicked the off button by mistake or something, right? So it's still, I can't, how? I don't, it doesn't register. Also, I haven't figured it out yet, but something happened in 2020 that made everybody stay home that year. Which means that instead of having the normal amount of users, I had very many more than that. And then, so on day one, the servers exploded. The AWS servers, like all the ones that we got. And it turns out that when you let Apache just spawn as many worker threads as you want for the number of requests that are coming in, it will, no matter if it has memory to do so or not. So we fixed that by giving them lots more memory. And then we discovered a very much more interesting thing. So AWS has a capacity that lets you provision load balancers. And for the uninitiated, a load balancer is a thing that lets you receive all of the requests in one place, and then they are automatically shunted back to all of your backend servers as necessary, right? And AWS in particular has a thing called an ALB, an application load balancer, which will automatically scale for your traffic, right? Which sounds great. And if you have a normal traffic pattern where the traffic kind of slowly ramps up over the course of the day and then slowly ramps down over the course of the night and then slowly, right, as a sinusoidal kind of thing, the ALBs will automatically keep up, and it'll say, oh yeah, the traffic's starting to go up, we better boot up another instance of whatever, right? If your traffic pattern is instead a straight vertical line right at midnight, followed by all of those users leaving again, the load balancers go, holy butts, that was a lot of users. We got to go spin up a bunch more servers. And by the time they've done that, all the servers have already left because they've already gotten their puzzle and or gotten a 503. Yeah. So it turns out you can't rely on automatic scaling when you're doing things that they did not expect you to do. So it turns out also if you ask AWS very nicely, they'll just make your load balancers scaled way, way up and keep them that way instead of auto-scaling, but you actually have to call them and ask. Their support team is so good. They helped so much. That was very fun, but that took us like a week to figure out because there were like 85 other things that we wanted to rule out first, because why would it be, this gigantic multi-trillion-dollar company's infrastructure? That doesn't make sense, right? So it took us a bit. That was fascinating. So now we've got this website and it's actually running smoothly. Why do people do Advent of Code? So like I said, originally my goal was to help people become better programmers. In the interest of doing that, it can be sometimes hard to figure out what problem you should work on, right? I want to go learn, Rust, or I want to go learn C++ or whatever. Do I just read the documentation? Do I just look up standard : string and start reading, and now I know C++, right? I don't ingest data that way, and I assume most people don't either. But it can be hard to know, well, what should I tackle then? What's too big? Right? What's too small and I won't learn anything? So I like to provide practice problems that let people sink their teeth into something and learn one or two skills at a time and then build their knowledge group. But people also turn out to use it for interview preparation. They use it for trainings at companies. They use it as a speed contest, which I don't recommend, but if you enjoy that sort of thing, go nuts. And to challenge friends with even harder versions. So if you see on the subreddit, people will make a part 3 and just make it if you're not using this wacky algorithm and the vectorization instructions on x86, you will not, okay, cool, that's awesome, right? So people do it for all kinds of things. And who are all these people exactly that do it? They're all over the place. They're everywhere in the world. Largely US, but that's mostly just because of the language, I think. In the US, it comes out at midnight Eastern time, which is where I live, which is why it comes out then, because that's when I'm awake and can be around to do the puzzles and can make sure the servers are running and also whatever, because I'm very much a night owl. On the West Coast, they come out at 9 p.m., which is easy for them. That's great. Sorry, Europe. In Europe, they wake up at 5 and 6 a.m., which is less good, and I'm sorry, but somebody's going to wake up early, and it's not going to be me. So, which leads to some people doing it in the shower before work, or, posting about how it's either very hard and or somehow stabilizes their sleep schedule, which is also, okay, that's not a benefit that I was going to expect, but whatever, that's very cool. People from all different skill ranges and domains and levels and whatever, 171,000 repositories on GitHub that contain the phrase Advent of Code somewhere in them, which is a lot. So there's C++ on the 4th most reported language on the Advent of Code unofficial developer survey. So lots of people doing it in C++. Also, that's so the little tiny bars are year over year, 2015 to 2024, left to right. So Rust is, which is kind of cool. Looks like it's eating Python for breakfast, which is fascinating. I didn't realize that until I was prepping for this, and it's it's what people want to learn right now, so that's what they're picking up. It's kind of cool though. But yeah, C++ holding steady. Number 4. People do it with programmable FPGAs, which I think is the coolest thing. I saw somebody doing with C++ metaprogramming. They like at compile time find solutions for the right. I love it. It's so much fun. Companies, you'll find a wall and they'll post all their solutions on the wall. Companies, universities, they'll do something like this is the Student Alumni Union in somewhere in Poland, I think. I forget now. Just print out your solution, put it up on the wall so everyone can share it, play together, right? Non-programmers, people solving it with graph paper, because why wouldn't you? You can, right? Because all I care about is the answer, so if you want to solve it like that, that's completely fine. Excel. One guy, the 2019 with all of the int code puzzles, which if you haven't done are very cool. Somebody did all of the int code puzzles in Excel, not by solving them, but by reverse engineering them using Excel, and basically built like an Excel-based disassembler for these programs. It was very, very cool. Google Sheets, right? A literal program manager Gantt chart software. Cool, great. Minecraft, right? It's great. So how do we build puzzles? So not just advent of code puzzles, but in general, like how do you construct a puzzle, and what should you avoid? The first really big trick is ambiguity. If I don't express to you the correct thing, it's very difficult for me to help you recover from the ambiguity, right? If I say something that can be taken multiple ways, even like a foreign language speaker, or just somebody that's kind of skimming and reading, it can be very hard to get them out of that hole where they're convinced that they've read it correctly when in fact that they didn't. So confusing sentence structure and multiple interpretations. I talk about have other people test the puzzle. That's largely to make sure that my English good, right, and not English bad. Expectations of outside information. So if my audience is going to be beginners as well as the crazy, incredible people who do wacky things with these things, I need to make sure that I don't start off by being like, all right, implement a B tree, and then everyone's already gone, or even just domain knowledge. Highlighting important details. One of the things that I like to say is for every sentence there is a user that somehow skipped only that sentence, like their brain shut off for a second, or they got like an alarm on their phone for a second, right? Extremely common for somebody to just be like, I didn't even realize that this was in here. So I try to help with that by providing examples where if you missed some key detail, the examples will fail early so that they see that there's something wrong. And then, having a bunch of beta testers that go through and test it and say, like, I don't understand this sentence, or I understood it, but I don't think people will. And I didn't think of it that way, right? Like using more brains than your own. In addition, advent of code puzzles in particular have a bunch of very specific constraints. I have exactly one answer that I'm checking for every input. So there are lots and lots and lots of input files. I'll get into what that means in a second. But I have a problem statement that is the same for every user, but every user gets a different input. So it might be like, this is a file that's just full of integers. Give me the sum of all of them, or something, right? Something like that. But every user is getting a different list of integers, and they're producing a different solution. In that case, the solution is the sequence of bytes that represents the base 10 representation of the number that they right, and they submit that. Any language, I'm not going to run the code. I both don't want to spin up a container for every single programming language in a runtime and try to it's a giant headache. But also, I don't want to restrict people to whatever set of languages I support. I want people to be able to learn whatever they want using these circumstances that I've proposed. Lots of inputs to make it so that everybody focuses on solving only theirs instead of being like, I'm sick of this puzzle. I'm just going to look up the answer, right? There isn't a the answer. Yours is different from your friends. Every puzzle has two parts. I talked about that a little bit. It is either, for the more involved, complex puzzles, I'll basically break it in half. And the first half will just be like, did you implement the outer loop of whatever this algorithm is appropriately? And then I'll move on to telling you now what to do with it. Or sometimes I give you the entire puzzle, the entire problem in step one, and then part two I say, what if instead you're multiplying them together? And everyone goes, oh no, I have to change one character. And simulate the real world, right? Because in the real world, you're not writing a piece of software and then putting it down and never touching it again, right? It's a continuous evolution. So simulating that a little bit, especially for beginners, in an environment where failure has no consequences, means that I can help people to learn if I had structured my code this way, I could have been able to adjust it more easily for what I thought might have been coming, and so I'm going to think about that. This time I super over-engineered it because you didn't ask me for any of that stuff. Now I overblew it, right? And help them to understand what it means to have to adjust code. Variety in types of algorithms, I guess, types of skills, types of interest, mostly to make sure that you're exposed to a bunch of different stuff. But that means that I have to figure out ways to express to a beginner without using any CS terms, like what I want them to build. I want you to build a star, but I'm not going to tell you that. So I'm going to say like, well, the elves are lost in the woods and they need to get from here to here, and also something occurs that makes BFS intractable, but I don't going to say that, right? Like figure out a way to like construct a scenario where hopefully you stumble upon the correct approach, or ask your friend, or learn a thing, or whatever, or maybe you figure out how to do it in BFS, or right? And then the tricky one, difficulty calibration. So a question I get a lot is, why was this puzzle way harder than yesterday? Or why was this puzzle way easier than yesterday? Why isn't it just like a linear progression from easy to hard? And the answer is because there is no such thing as like a single number how hard this puzzle is. It depends a lot on what your background is, and your comfort level in the language, and your comfort level in the algorithms, and whether you've, lots of personal stuff. So it's different for everybody. And so I try to mitigate that by managing the amount of complexity. I try to include a simpler version of a puzzle coming later, so that you do the early puzzle, and then you get to the later puzzle, and like, oh, I've already seen this, as opposed to if you hadn't gotten that, you should like run into a brick wall because you've never encountered something like that before, right? Whether or not I think people are going to have more or less time, like weekends versus weekdays. Variety, because if everybody has a different background, then doing a whole bunch of like assembly problems all in a row, if somebody doesn't like those or isn't good at them or whatever, right, just like cause them to burn out. Progression, both based on versions of harder and easier puzzles, but also kind of making them increasingly complex or involved. Throwing off the difficulty a little bit deliberately. I'll sometimes like to put a tricky puzzle early on. And people, this is very contentious, but this is my reasoning. Early on in the month, everybody's like, oh yeah, a day 5 puzzle? I can do a day 5 puzzle. I've done day 5 puzzles in the past, and they tackle it full force, like, yes, I can do this, right? And if it's a day 20 puzzle, same puzzle, right? It's a day 20, like, oh, day 20, oh, that's too hard. I'm gonna drop out. I'll do it next year. It's fine, right? But if I put a trickier puzzle earlier on, everybody says, oh, a day 5 puzzle, I can do it, and a bunch of them do it, and they learn a thing, right? As opposed to like having it labeled like, this is a hard puzzle, caution, do not attempt, right? Like, no, Drew, try it. Even if you get a little bit in, you'll have learned a thing, and that's okay. So, and also, easier puzzles later on in the months that people don't get completely burned out by a bunch of like deep theory or something. And then also, C++ programmers will enjoy this, interpreted versus compiled languages. One of my goals with the puzzles is to make it so that interpreted languages have no disadvantage over compiled language in terms of runtime. That can be tricky. Fortunately, big O goes above squared. So as a result, I can construct a circumstance where if you use a very naive algorithm, like a linear scan or a big O factorial, whatever I feel is not the thing I was trying to show the user, right? The intended set of experiences, the range of experiences that I want you to have. I will try to calibrate the input data so that if you do run that naive algorithm, even in a very fast compiled language, a handcrafted assembly or whatever, I don't care, whatever you want, it'll still take several months to finish, right? It's still intractable. But if you do it in one of the approaches that I would like to expose you to, it'll run fast even if you're in Ruby or Python or Perl. That can be tricky, but it means that when I'm beta testing the puzzles and when my beta testers are beta testing the puzzles, I will very often, for the ones that are runtime sensitive, implement them in Perl and in C++ and in a couple other things, and my beta testers will implement them in like Haskell and all kinds of stuff just to see like, is this sane? Maybe, sometimes, hopefully. Sometimes it's not. It's really hard. I get it wrong a lot, but I try to make it as careful as possible. So how do you make an advent of code puzzle? This is the general process. I start by getting inspiration from someplace. So most of the puzzles come from some real-world problem that I've actually encountered in my work, either my hobby projects or my job or my whatever, or I see a video of somebody doing a cool thing, or I see a mechanic in a video game, right? But it's like somewhere like, oh, that would be neat if I tweaked these things and made them do this. Some kind of inspiration. And then I go and research to see, like, is this just like a solved problem where everybody's going to type import iter tools and then they will be done with the puzzle, which happens, or whatever, right? And then design around pulling out just the part that's interesting, but in a way that I can frame it to a beginner in a way that it will make sense and not take 16 hours, hopefully. Sorry, I try. And like design out what I want it to look like. And then I build 3 programs. I build something that will generate inputs for that puzzle, in no particular order, right? Something that will generate input files for that particular puzzle, and then a program that will solve part 1 and a program that will solve part 2. And I do that to have both runtime constraints, like I was talking about, but also so that I can have a lot of assertions scattered all across all of these things that say, if you don't encounter, moving left, up, right, and down while solving this puzzle, throw it out and build a different input, right? And so in doing so, I can generate lots and lots of inputs, all of which have a similar set of constraints for the users so that everybody has a relatively fair experience when I'm, to the best of my ability, which I feel like we do pretty okay at. But sometimes the input generators are just like, it's a random number, and then the puzzle uses the random number for some interesting thing, like it's a seed for a hash function or something like that. And sometimes the inputs are super elaborate, so depending on what kind of puzzle it is, sometimes you start with the solvers and like work backwards to inputs, and sometimes you start with generating arbitrary inputs and then work forward to solvers. Then you finally use those 3 things to generate many inputs and solve them, and finally write a story about how the elves dropped the sleigh keys in the ocean and put the coat of paint on it that gives it a narrative that actually ties it together. That's like the very last step. But you might think that these just kind of flow nicely to each other. It's kind of like this. It's noodly, and very often I'll have to throw out an idea, or I'll be implementing the solver and suddenly discover that there's a library where you just like hand it this file and it just gives you the sometimes that's okay, sometimes it's not. Just very, we get there. We get there eventually. So here's some example puzzles. This one says, how many square inches of fabric are within 2 or more claims? So this is a list of claims of fabric. There's a giant piece of fabric, and everybody's going to have some rectangle where they say, at these coordinates, with these dimensions, I'm going to cut out this slice of fabric. How many square inches of fabric are within 2 or more? There's going to be 2 people trying to get that same slice of fabric. And people love to visualize these. And it's one of my favorite things about Advent of Code is they will take the inputs and they will turn them into a picture that looks like this. And if you haven't spotted it yet, there's the only ID that doesn't overlap. There it is. Yeah, just, I'm sure you all found it already, but just for the, yeah. Here's another one. So one of the things that weirdly I kind of enjoy is log parsing and log analysis. So one year I produced a puzzle about log parsing and log analysis. And of course I used dates that you can't represent with Unix epoch time from 1518, because I'm mean. But it produces this set of logs. And it asks you things like, find the guards that has the most minutes of sleep. It says, like, this is the guard that's now functioning. They wake up, they sleep at certain times. Like, do some very minor date math. And then it says, of all the guards, which one is frequently asleep the most in the same minute? And some people will take that and load it into, like, data analysis toolkits and make graphs and charts to solve the puzzle, which I think is delightful. I love it. And some people will visualize it by having the elf defend the lab, and that's the story. And then they fall asleep for a bit, and then they wake up, just to get a sense for what the data looks like, which I think is great. This is a puzzle that I really enjoy about filling up water on a 2-dimensional grid. So the water falls in from the top, and then there's these buckets that fill as it goes, and it has rules about how they overflow and where, and then it asks like how much water is there or whatever, right? And so people will make like full-on animations of the water flowing and filling and doing whatever, which not only is just very fun to look at, it's also good practice for these users to be able to play with and inspect data, because that's an important part of being an engineer, is to be able to understand this data, this problem that you're looking at, and share it with others and explain it. And it's also an excellent tool for beginners, where they'll say, I don't understand what Eric is talking about on this puzzle. This makes no sense. And then they go to the subreddit and they say, okay, got it. Okay, right? And I don't have to build so much tooling and information and diagrams and designs if the community is able to support one another, which also helps give other people practice teaching one another the thing that is the current subject of everybody's mind, because it comes out 1 per day and everyone's working on the same, right? Etc. There it is. So I'm a Perl programmer. I like regular expressions. I'm not sorry. This is a puzzle that gives you that top line. That top line is a regular expression that matches north, south, east, west. It matches any string that represents a valid route through a maze. And so the thing on the bottom is the maze that string represents. And your job is to figure out, I think, what is the most distant point from the starting point by reconstructing the maze. I forget, something like that, right? by not actually running the regular expression, but by decoding it into a tree. It's not much of the syntax, right? And then figuring out based on that where the branches are, and then following them and doing a little bit of recursion, and then figuring it out. So somebody animated the regex processing into the maze, which I love. Any of the maze ones always produce really cool visuals. This is one that says, here are a bunch of points. What is the closest location to any of the points using the following distance metric? And then it says how much of those regions are finite, which I love, because anytime I include infinity in a puzzle, half of the people just like, what? If infinity, then? No, that doesn't work. What am I supposed, right? Like, it's really fun to see how people handle those sorts of circumstances. So people here know about Conway's game of life. Everyone knows Conway's game of life, right? In general, that's a field called cellular automata. If you're not familiar, go look it up. It's so much fun. This is a cellular automata where there are 3 states per cell instead of 2 states per cell. And the question is, there is open grass, which is white, trees, which are green, and logging camps, which are brown. And they're, the logging camps will log all the trees nearby, and then they'll follow the trees, and then they'll be torn down afterward. And it ends up making these really cool spiral patterns as they follow the growth of the forest in the story, whatever. And then the question was when does it start repeating? When does the spiral patterns that all of these make start repeating? And I guaranteed that every input produces a spiral pattern because I knew people were going to do this, and they did. And all of a sudden, the subreddit was just full of people with cool spiral patterns of these. So we do puzzles like that. We do puzzles in 3D space. This one says there's a bunch of points with a bunch of velocities. Which ones collide and where? So somebody rendered it in, I think this is GNU plot. And a bunch of them go whoosh back and forth with each other and then go flying off into the abyss. And you have to figure out when is it safe to decide that all of the points that would have collided are going, or have done so, and then figure out which points they were. One of the things that we calibrate for during these is how long it's going to take for the top 100 solvers. Mostly because that's when the points are there. So the people that are there for the speed contest that are doing it for the points, that's when it matters the most that the site is completely functional, or else the day is invalid because a bunch of people that wanted to compete couldn't. And also it's how long I stay awake to stare at the server's minimums, how long it takes for the leaderboards to fill up, right? Plus, usually 3 hours, but at the least. And so this is a report of just a histogram of how many puzzles have taken how many minutes to solve. You should not measure yourself against these times, though. A lot of people like to how come I'm not on the leaderboard? I'm so good. I'm such a good programmer. It's because these people aren't doing software engineering. They are doing wild shortcuts and do nothing but programming contests for fun all year round. That's all they do. The code that they're writing is not code that if you gave it to me to go into production, I would pass, right? Your code review would fail instantly, and also I would question our hiring decision. Don't hand in code like this. But the people that do it very fast do it very, very, very fast, usually within, the spike here is, what is that, between 5 and 10 minutes, or something completely bonkers. And then they post all their solutions, and they post videos of themselves doing it. It's really fun to watch, but it's not, it's a different thing from writing software. It's still cool, though. So we've had some growing pains, because we're not 70 users, it turns out. Still don't understand why, but I'll take it. So we've had some growing pains. We've had some learning experience, what I mean to say, right? So step 1, how should you prioritize tasks when you're working on something? The way that I used to prioritize things is step 1, a thing happens. Step 2, handle the thing. Step 3, go to 1. Easy, you handle all the tasks, it's no problem at all. I mean, everything is top priority. How do you prioritize tasks if you have 1.4 million users from all around the world of all different backgrounds? Well, step 1, thing happens. Step 2, handle the thing. Step 3, while you were handling the thing, several other things happened. Step 4, handle those things, but more things happen. Step 5, never sleep. Don't actually do this one. So you actually need to stop to prioritize things. It turns out, surprise, right? You actually need to say, is this one email that I got from this random user as critical as the entire website being down? No. Even though I got the email first, I should probably pause that and do this other thing. Actually ask for help. This is something that I struggle with. I mentor a bunch of engineers, and it seems like it's a more widespread problem than just me, but being willing to ask others for help and to admit that you aren't capable of some circumstance, especially as an engineer where it's your job to be very, very smart, right, or whatever, right? Like, to be able to say, like, I don't know or I'm struggling is so important, and it's okay, and you're allowed to not know things. The whole point of Advent of Code is that you don't know a bunch of things, and then you do them. Write better documentation. This mostly is for me to write down, like, how did it, because I only do this once a year, right? I mean, like, I work on it all year round, but like, I only run the event once a year. It's like, how are these web servers set up again? Like, what is it? What is this? Apache? How do you restart Apache? Right? Like, having all that stuff written down so you don't have to keep it in your brain. And it's an incredibly supportive community that helps itself. I don't know how to get this one. I have it. I don't know how to cause it. I do not have recommendations for how you can have a community like this. But having it means that, like I said, I can just post a puzzle, and then instead of all 300,000 people or however many are actively working on it that year, people asking me for help, which is what they used to do, now they ask each other for help, which is actually scalable and not death. Automate tasks and provide self-service tools. I have been doing this more and more every year, and I thank my past year self every year because of it, to have tools that just like, oh, I need to touch this row in a database. Like somebody sent me a payment, because you can send money. You don't have to. It's free, but you can send money. And if they do, sometimes they send it for the wrong year. Like, oh, can you just up this to be 2024 instead of 2023 or whatever? Like, yeah, sure, that's fine. Like, each one of those takes time. Or like, hey, can you please merge these two accounts? You can, like, right? So every single thing of those that I script means I don't have to remember how it works. It's way faster for me to do it, and it's way less error prone. So they are administrative tools literally just for me, because then I can encapsulate all of that and not think about it, which, like, most of my projects don't get that much traffic, so none of this stuff ever has mattered for those. Like, yeah, sure, at work, yeah, but at work, like, there's a ton of people that are, like, operating the system that, of course, they need a fancy web UI. Like, mine's just, like, a command line thing, but, like, it turns out to save way more time than even I predicted, and I love automating things, so. Accessibility. Turns out when you have lots and lots of users, even if 1% of the population struggles with something like colorblindness, right, or something like that, that's a lot of users all of a sudden. So making sure that you have accessibility guidelines, you carefully test your accessibility guidelines, you take accessibility feedback very seriously. I treat accessibility problems as incidents, which I especially like. They are prioritized based on the number of users affected, just like you would with any incident. So if you have a site outage that's affecting 100% of the users, as opposed to this thing is unreadable for some, like, people with color blindness, I'll bring the site online first and then I'll write prioritization. But it is an outage for some users. Some users cannot use your website. Test your accessibility. It's easy to fix. We get denial of service attacks. Why would you attack a programming puzzle website? I don't know. It makes no sense to me. I don't know if people are, like, mad and then spin up their botnet army or something, but, like, we get completely annihilated occasionally at random. Sometimes 0 times in the month, which is great. Sometimes, like, 2 or 3 times. It turns out AWS provides you really good tools to do this. They cost some amount of money, but it's still better than having just an outage until they stop hammering the website. But I would have never expected that I would need to deal with something like this. But we will just all of a sudden get, like, legitimate DDoS traffic. I don't know. Here's some frequently asked questions. Why do the puzzles unlock at midnight UTC -5? Or why don't they unlock at a different time every day? So they unlock at UTC -5 midnight because that is when I am awake and I am a night owl, and that's when I can watch the servers, and that's when I can guarantee that every single day for an entire month I will be around and not have family obligations and not have to be doing something for my job, right? Like, it's like a block of time that I have to be 100% sure I can be up for every time. Why don't they unlock at a different time every day? So we very often have people saying, hey, did you know that with 25 puzzles in 24 days, you could rotate it an hour every day and it would do a complete loop? And I say, like, that is true, but then I would die, and so would all the users. Please, like, can't. Like, the sleep schedule rotate, you can't. So it's when I survive, and I'm sorry, but also, like, that's how I operate it. I have to. How long does it take to make 25 puzzles? I usually I collect the inspiration for the puzzles continuously, year-round. I just have a giant list of puzzle ideas. To actually construct the puzzles, it is at least several months of all of my free time, working every single night for, like, 2, 3, 4 months, depending on how involved they are and what I'm doing. Like, when I did Encode, which is a virtual machine that you build over the course of the month, that was the 2019 one that I mentioned, That took forever, because I built an entire compiler toolchain for that one virtual machine that I invented for the purpose of this puzzle suite. That took a long time, but like it varies. Designing and building the calendar, coming up with the theme and all of that stuff usually starts as early as like April. So I take like 3 months off, and then I do this, and also my actual job. It's a lot. It's a lot of work. Can I send you puzzle ideas? Please don't send me puzzle ideas. I do not know the intellectual property of the puzzles that I get ideas for, so I do not read puzzle ideas if people send me them. I get emails all the time. They're like, I came up with this cool idea. I delete the email. I don't even look at it, because I don't want it to be in my brain to begin with, because I don't know if you like just ripped that from somebody who's now going to sue me because I used their super clever whatever. It's not worth it. Also, I have plenty of ideas. I have a giant list that I'm always adding to. That was the thing that I always expected I would run out of first, is puzzle ideas, and it hasn't been somehow. So please do not send me puzzle ideas. How do some people solve the puzzle so quickly, or are they cheating? Before LLMs, we got this question all the time. With LLMs, we still get it all the time, but it also says, are they using LLMs? The answer is no. Surprisingly, they're not cheating. They're just very, very, very fast. I talked about this a little bit, but the people that do competitive speed programming year-round are not doing the thing you think of as engineering, right? But they are solving the problem very quickly. And so usually what they will do is they will scroll all the way to the bottom of the puzzle. They will look for the line that asks, like, how many widgets are in the Frobnicator? And then they go look up the words widget and Frobnicator in the puzzle. And while they're doing that with one eyeball, they are coding up the solution with the other eyeball. They did not read the puzzle at any point. Some of them go back and read the story afterward, because they screen record themselves doing this. You can see them, watch them doing it. At no point did they read the puzzle. Sometimes they glance at the input file. Sometimes they don't even do that, and they just guess at the kinds of things I'm going to ask, because they do these things so frequently that they can kind of guess at where I'm going to get at, and they code up a solution for something that they think is right, and very often they got the right answer, and they move on. It's very different from what anybody ever pictures, including myself. With LLMs, I ask people not to use LLMs for the purpose of getting on the leaderboard, because if I let them use LLMs to get on the leaderboard would be all, 3-second times for the ones that LLMs can solve, and none of that for the ones that they cannot, and that's lame, and I don't want that. So instead, please leave the leaderboards for humans. If you want to use LLMs to just solve the puzzles because you're practicing prompt authoring or something, that's fine, but I don't think you're going to learn programming doing that. That you just do, go for it. Yeah, but if you want to at some point look up, and also, the people who do them quickly write blog posts afterward of here are these speed techniques that I use, and it's just like a different universe. It's so cool, though. Look up screen recordings of people doing fast advent of code solves. It's wild. It's so cool. I've also got some fun stories for you. As the non-participating mother of a 14-year-old who got up at 4:50 a.m., I'm both massively impressed that people do this and somewhat baffled that nothing else has this effect. I've been reading here, the Advent of Code subreddit, so I can make sense of the conversation later in the day. So this is a parent saying, my kid does Advent of Code and then is talking about Santa and elves and bee trees, and I have no idea what's going on, so I'm just here reading all the posts you guys post so I can try to figure out some way to decipher what my kid is talking about. I love these. I love stuff like this. I did not expect to have this kind of reach, but the fact that there are kids that are doing this stuff and learning this is magic. I get tears. Help me get a job. I get emails like this quite frequently too, but people also posted in Reddit hey, it helped me prep for an interview, or because I was able to sharpen my skills on this language, I was able to get a job in this field. That's incredible, right? More power to you. That's amazing. I never expected that either, right? It's very, very cool. My son and daughter are becoming more interested in programming because of your site. Oh, and there's one other one. Can I go back? Is there? Yeah. There was another one where there was a polarizing, we'll say, puzzle that involved implementing a combat between elves and goblins, and it was just a lot of text and a lot of instructions, because in order to disambiguate pathing for units on a grid, you had to identify not just, have the elf move toward the goblin, but the elf needs to make sure that it moves in such a way where it's heading to the closest adjacent square to the goblin, to the elf at its starting position, And also, if there's an ambiguous step, whether it could go left or up, it needs to pick this one in this order, because otherwise you end up in a state where an alpha is in the way of another one and then get the wrong answer. So there's a lot of disambiguation. But I wanted to include something that was kind of akin to like real game design, game development. And a lot of people are like, this was too much text. And I agree, it was too much text. But I also had people emailing me being like, this project was so much fun because it got me exposed to this stuff. Or I had people emailing me like, my kids saw me programming something that looked like a game and came over and sat with me as I was working on it. And I was able to show them what I was building and why I was building it the way I was and teach them programming, and now they're into programming. Like, oh, that's amazing, right? How cool. So it's just, I don't know. We get stuff like this all the time. It's also used as midterms, exams, question mark? This one's from 2016 or 2018, but there's like every year universities are like, hey, can we use some of your problems for this class I'm running? Like, yes? Also, hi, why, really? And final exams, because why not? So, in conclusion, engineers in your organization should solve puzzles for fun. Actually, everyone should solve puzzles for fun. Thank you.